Hello and welcome to my student project demo for Hub21. So just to begin with my own student profile, I began coding with Hub21 around a year ago, and we started by learning very basic hard skills like lists, strings, defining functions, different loops and imports and things like that. And then we went on after the introduction to Python. We went on to actual modules that go into more specific parts of coding. For example, right now I'm learning the algorithm module. And the most recently I've been doing projects on the using search algorithms, and which I'm going to be presenting right now. So the project that I'm going to be presenting now, including search algorithms, is the minimum loss one. And the description is that a character Lauren has a chart of distinct projected prices for a house over the next several years. She must buy the house in 1 year and sell it in another, and she must do so at a loss, but she wants to minimize her financial loss. So here we get the input of n, which is the number of years of house data we have, and the second line contains n space-separated long integers that describe each price of the house in each given year. So here we can see that on line 67, we began with taking some inputs like list or LST for short, and a for loop turning all of the numbers in the prices list to actual prices, so actual integers. Then above we have a naive version and a non-naive version of the minimum loss function that basically do the same thing, but the difference is that the naive version is more time complex than the non-naive version. So here starting off with the naive version, we began with defining minimum as a very large number that can easily be replaced with another smaller number, and two for loops. The first for loop is x, which is in the range of the length of the list. So it would go 1, 2, 3, up until the length of the list. And y, which is the number containing the element that comes after x. So then we say that if the list with the list index x is larger than y, and if the list of x minus y, so the difference between them, is smaller than the minimum, that difference replaces the current minimum. And we go on like that until we get the smallest minimum possible. And then with the second function, the non-naive version, we basically do the same thing except it's more condensed. So first we define n, which is the length of the price, and the minimum, same as the other function. And this time we define a new array that is the same as the prices list, but sorted. Sorted meaning that it goes from the smallest price to the largest one. And here we have a for loop where I is in the range of n minus 1, and we have num, which is the difference between two numbers or indices that are together. And then we check saying if num, so if the difference is smaller than the current minimum, and I came after I plus 1, and the larger number came before the smaller number in terms of the actual prices in the house and the years, then this num can replace the current minimum. And yeah, so basically the same thing, except one is more time complex. And in this project, I learned more about how to turn a non-naive version of a certain function into, a naive version to a non-naive version, so reducing time complexity, and I learned more about search algorithms in general. I'd say my favorite part of this project process was probably just figuring out how to approach the problem, and I think the most challenging part for me personally was figuring out how to change the naive version to a non-naive version. And yeah, thank you for watching.